Good morning, superhumans! First, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, today we have a bit of a task ahead of us, and you can keep me company. Let's switch to that view. If it'll change, come on. There we go. Okay, so this is video from my phone. Oh, and also, a little warning. I didn't get to sleep until about 4 o'clock this morning, so right now I'm surviving on caffeine and good intentions. So we'll see how long the good intentions last. The caffeine will probably hold out, but we will see. So these are boards that I actually ran through the tester yesterday, but that's not all of them. Anyway, I should back up a little bit. I'm getting ahead of myself. What is going on? Oh, right. So, Sion, yeah, it was a terrible plan to build a mini factory. All right, so, what are we doing today, folks? I had actually been thinking about skipping this live stream because I've got a bit of a time crunch going on with testing all of these boards. Those are some of the boards there. That's not quite half of them, and those are the ones that have been through the test process already. And so the backstory is that these are conference badges for Linux Conf AU 2021, and many of you will have seen these on the live stream previously. They look like that, and if I switch to this view, it looks like that. So it's an electronic conference badge, and it has a Lowland 32 light on the bottom, so it's got an ESP32 on it. There are a couple of 128 by 64 OLEDs, and they are mounted over buttons, so the OLEDs can be used as touchscreens. Essentially, you push the touchscreen, you push the screen, and it clicks the button. Same as like the free deck trick, which is really, really cool. And it's got spots for lanyards up the top, so you can use like J-hook type lanyards, 2 of them there or 1 in the center. And it has these headers on the side. Excuse me. It has these headers on the side for add-ons. Oh, that's something I didn't think about preparing to show you. Add-ons, add-ons. Oh, here we go. We've got some add-ons. So I'll bring over a couple of these. Here are some others. These little headers up the top here, the 6-way header, SAO, simple add-on. I designed so you can plug different things in. And it has ground 3.3 volts, I2C, and 2 digital I/O lines, like GPIOs. And then you can make things like little add-ons. You can put your own circuit onto here and make an add-on. So you can think of it conceptually as kind of being like an Arduino and Shields, except that it's a conference badge, and then bling. And the bling can be something pretty like this, designed by, so this PCB was done by Andrew Nielsen from the local hackerspace, and that's so cool. I love this one so much. And it's symmetrical. It's got the PCB batch number on the back, but if we put it over this way, that plugs in, and then we've got a little tux, a crystal tux, attached to the conference badge. So, yeah, so the Open Hardware MiniConf team this year has been working on creating these badges for LCA 2021, and we are about at our shipping date approximately, because we have to allow for shipping, losing track of which one's which. Okay, that one. I'm doing things that I shouldn't, which is moving them around without paying attention to what's what, and possibly mixing things up. So what we need to do is get these tested and firmware loaded onto them and posted out to a couple of hundred LCA attendees. And I've already talked about this a bit in the past. I'm not going to go into that in great detail today, because what I need to do is get through testing a whole bunch of these so that they can then have their final firmware loaded and they can be posted out over the next few days. And that way we can be pretty sure that they will arrive before the conference starts, which is late-ish January. It's like 23 to 25, I think, of January, or 21 to 23, something like that. So we've got the Christmas shipping period and we need to get them out. Now, there were a couple of failures in different ways that we found. One was there was a very high failure rate on the OLEDs, and I've talked about that in the past. So I ended up testing every single OLED. I've tested more than 700 of these now before they were soldered onto the carriers. And we also tested every Lowland before it was soldered on, because we didn't want to go to the trouble of, like, say you've got one failed display and you've soldered everything together, then effectively you've also sacrificed the other display and the Lowland, because taking these off and reworking them is quite painful. Better to discover you've got dodgy parts before you start than after you start. But the actual point of what I'm going to be doing today is the testing of the final assembled units. So this is the last line of defense, I suppose. It's the last chance we get to test the whole thing as a complete unit before it gets posted out to someone, and we want to make sure they work. And so, once again, I've talked about testing in the past as well, but today what I'm going to be doing is going through a whole bunch of them, and let me just find a URL, because there are a couple of other things that I really should talk about in relation to this. Alright, so if you're coming along to LCA, and by coming along I mean attending virtually, and you have an interest in open hardware, you really should submit a talk. Here we go. We have 4 mini-confs. Let's, I'm just finding a, alright, I'm going to drop a URL into the chat. This is the link. Mako said, so it's a virtual fair. Yeah, kind of. So LinuxConf AU is a 1-week conference that happens every year in a different city around Australia or New Zealand. But because of COVID, the decision was made that LCA 2021, which is in January, is going to be online only. So it's shrunk to a 3-day event over a weekend, like an extended weekend, instead of the usual 5 days, and it's all online, which is, it's the first time it's ever been done, forced by circumstances. But I think this will be really interesting because it's going to lose a lot of the things that are great about LCA, but it also adds things that that haven't been possible before, like allowing people to participate when they couldn't necessarily travel to Australia for a conference. So it might be a good opportunity for people who wouldn't normally be able to take 5 days off work to travel to Australia for a conference. Maybe they can come along and participate online. It might make it a bit easier to access for a lot of people. So it'll be very interesting to see how this all turns out. And it puts some challenges in place in terms of how the open hardware mini-conf in particular can interact with people, because traditionally we do a hardware assembly session at the start of the conference, and people get a chance to learn how to solder if they've never soldered before. But we can't do that sort of hands-on thing. And this year, the first year, the conference team have decided to go for an electronic conference badge. So we're using this as a bit of an entryway and a focal point for people that are interested in hardware, so they can get the conference badge and they can hack on it themselves if they want to. And hang on. Here are some results. No, I've got an Android tablet in front of me, and for some reason it's listening to what I've been saying, and it's just come up with some search results on some random thing. The conference badge is it's a way to provide a focus on a project for people to work on, and we're also hoping to use it as a way of overcoming the barrier that's put in place by having people distributed and not all in the same venue. We want to try to figure out ways to use the badges as a mechanism to communicate between people. So that's one of the reasons that we wanted to have screens on it, so we could do things like send messages. The badges will be able to use Mqtt, so we can pass messages between badges. You can set up badge-to-badge communication, or we could do broadcasts or whatever. So there are lots and lots of things that could come out of this. So it's even though COVID has thrown us a curveball and we can't have LCA in person in Canberra as we're expecting to this time, we're taking a bit of a different approach. And yeah, there is like an interim LCA team. So LCA 2022 is going to be in Canberra, and that's what was going to be LCA 2021. Basically, the program has been pushed back by 1 year, and there is now this interim online event for LCA 2021. So that brings us to today's task. I have a big spreadsheet with a list of people who have signed up for LCA, and I need to post badges to them. But that URL that I posted in before. All right, getting back to that. If you are attending LCA, please think about submitting an application to do a talk at the Open Hardware MiniConf. And we're going to have slots that are 15 or 20 minutes. So it's not, they're not like 45-minute talk sessions. It's not a huge burden to prepare a full-length talk. It's like halfway between a normal conference talk and a lightning talk. And I think most people, if they've got a project or an idea or something that they are enthusiastic about, they can talk for 15 minutes about it. So if that sounds interesting to you, please check out that URL that I dropped into the chat and submit a proposal to talk at the Open Hardware MiniConf. Now, all right, where we are, there are a few interesting things about this whole test process. Eventually, what I'm going to do on this live stream is get into a cycle where I'm just sitting here with badges. I'm going to have untested badges, the tester in front of me, and I'm going to have a little shelf here for like a rack for putting the tested badges onto. There's a place for badges that have failed the test, and I'm going to be cycling through them. But first, I'm just going to explain a little bit about what I'm doing. And once I get to that point, I can probably just pay attention to the chat and talk to you while I'm being the robot in the process. All right, so now this tester, let's just go back to here. Now the basic problem that we have is we need to test a variety of things on these badges. First, we need to check that the screens work and that they are around the correct way. These two screens have different I2C addresses. So there is a left screen and a right screen. And if the messages come up reversed, then we know the screens are being put in the wrong way around. That's something that I have to visually inspect as I'm doing the test. We also need to know, well, voltages will be okay because if it's running, it's running. So we're not going to bother testing that. What we need to test is that there is a connection to each of the digital I/O pins that are exposed on the side headers and on the SAO headers. So we need to know that the ESP32 on here can communicate and control each of these pins individually. We need to make sure that there are no shorts between them, because what can happen is if you've got a flaw on the PCB or if you've got a solder bridge, for example, what can happen is that you can, say, assert one digital pin, and if you read from another digital pin, it will follow the state of the first pin because there's a solder bridge. So we need to detect solder bridges. We also need to detect that the buttons behind the screens are working. So I need to manually click these and have the system detect it. And we need to check the touch sliders. So these things that look like funny alien symbols, I love these so much, are actually touch sensors. And if I get the light angle just right about there, you can see that these are overlapping triangles, and there is actually a touch sensor on the bottom and a touch sensor on the top, and those two sensors interleave with these fingers that go past each other, and proportionally there is more area as you get closer to one end on that surface and less surface area on the other end. So what we can do is we can detect contact like just touching in that point, and we can also detect approximately the position by measuring the relative signal coming from those two touch sensors. So we can use this as a slider. So you could use that like a menu slider or something, or you can just touch on here to tap up and down. So what we can do is like a threshold detection to see if you've tapped one of these, or we can do a comparison, like a proportional thing, to see if the slider is working. So I think that's all we have to test. Oh, and there's Wi-Fi and and things as well. So something that I've been thinking about doing a video about for a while is a technique that I've often used when I make testers. So I often make custom testers as well, and I'll just show you an example of that. So this is a tester for the free NFET 3 module, and this shield was specifically designed to be nothing but a tester for the module. And you can see it's got pogo pins on here, so the module sits on top, and when you press it down it makes contact with this button. So if you push it down far enough, the button clicks, the tester detects that you've put a module there, it runs the tests, and then it's got LEDs on here for when the test has started, and then it goes up to a green for a pass or down to a red for a fail. And there's a buzzer on there as well, so if it fails it makes an awful squealy noise. So you can just put the module on, push it, and it goes pass, and you put it aside. Push it on, it says fail, you put it aside. So this is a custom designed tester. I've designed many testers like this. That's just one of them. I've got a whole row of them on the shelf up there for all different devices. Oh, and also terminology. The standard industry terminology is that the thing you're testing is called the device under test, or DUT. So you often see it abbreviated to DUT in documentation. And so if you don't want to go to the trouble of designing a custom PCB, now for that particular thing it was worth designing a custom PCB because there are thousands of those modules produced and they need to be tested very quickly in the factory. And normally it would be more than that. That structure was basically just the PCB with the test probes. Normally there is a laser cut body around it which acts as a guide for the module. So the pins come through a plate and then the module sits on top, and it's always aligned with the pins. But there is another technique that I use fairly frequently, which I think is a kind of handy little trick, which is using an unpopulated version of the PCB of whatever it is that you're wanting to test to build a test jig. And that's what I've done for the swag badge. So what I've done is made up this test jig, which has got some 3D printed parts and some spacers and a couple of PCBs, and you can see pogo pins, and it's also got a Lowland 32 on it, so it's got an ESP32, but it doesn't have the OLEDs. And one of the reasons, basically the trick here is that if you have, I mean, you can't always do this. It depends on the design of the board that you're wanting to test, but often you can, and in this case we can use this trick and it works out pretty well. So what you do is anywhere that you have a through hole in the PCB where there is a contact that you want to test on your device under test, you solder a pogo pin into that location, and then you can use a processor either directly on the board or another one that you patch in with bodge wires to make contact to those points. So let's chuck this under here and I'll show you what I mean. So these PCBs, and there are two PCBs here separated by 12mm nylon spacers with some M3 bolts through it. So step one is to get two blank PCBs and bolt them together with the spacers. Now you can do it with just a single PCB, but my preference is to do it with a pair of PCBs. and the reason is that it gives you excellent alignment on the pogo pins. Because these are separated, what you can do is put a pogo pin down through here and it's always going to be perfectly aligned because it goes through both PCBs and they're a fair distance apart. So I've got a whole bunch of pogo pins here, all different designs. Turn it around that way. So most of these are the P75 series, but I haven't used P75s on this one. I've used some longer ones. Now the reason, so these P75s, and you can see the second letter on there, that's for the style of the head on the pogo pin. So this is the P75B1, which is just a sharp little point. That's a good general purpose one. LM2, where's that one? LM2 is like a little conical head. And I think this one has got, yeah, it's got little sharp edges on it. So it's not just a simple cone, it's like the tip of a drill almost. And B1, what's this one? Oh, that's needle point. Oh yeah, it's more of the same. We've already seen those ones. LM3, I use these ones a lot. So the LM3s are a slightly bigger size. We just saw the LM2. The LM3, you can see it's got like a serrated conical head on it, and it's bigger than a typical through hole. So a lot of through holes are like 0.8 millimeter, 0.9 millimeter, give or take. It's sort of in that ballpark. And that head is big enough that it won't go through the hole on the target board. And then there are others as well. There are bigger ones like this that have just got a rounded end on them. What are these? More of the same. And you can also get mechanical ones like this. So this is a guide pin. In fact, this one's so big that it doesn't really go under the microscope. But you can see if I push this one in, you can see the back of the spring-loaded shaft coming out there. So this is the sort of thing that you use as an alignment guide. And this would go through on the carrier PCB. So you would use this with things like, let's see if I can get a good angle on this. So this is a hole for M3 bolt, so that's I think a 3.2 millimeter hole. And on this, you know, if we had this on the test PCB, you can use that as a guide. So it will sit in that hole and then it'll self-center and then be depressed as you push the board down, and it keeps it nicely aligned. Oh, that went through. So that one's slightly too big for that size. You would use it on a hole like that. So you would get it approximately aligned, push it on, the PCB would self-center and then depress to its test position. So there are lots of different types that you can use. What I ended up using on this tester are these ones. So these aren't P75 series, these are an extended type, and it's got a head like the LM2 or the LM3. I think these might be LM3 size. I don't have a label on it. It's got a little, you can see it's got a little conical head on it, and the head is slightly serrated so that as it pushes onto a PCB, it'll make good contact. So if we've got a PCB here and we wanted, the brightness is a bit high for the camera. That's better. So if we've got a PCB here and we want to make a test contact, this pin comes in and it pushes into the hole, but it doesn't go through it. It makes contact with the edge of that. And you can see I can push that and it's not going in. But the serrated edges on it mean that it makes good electrical contact. It'll push onto there, make contact, and then you can do your testing without having any headers or anything soldered on. So yeah, this particular style of pogo pin is good for these quick DIY sort of test jigs. Yeah, so I'll just chuck this away because I don't want to leave too much mess lying around on the bench. I want to get it cleared up before I start doing things for real. Right, now, oh that's right, I was talking about the tester. Okay, so step one is you take the two PCBs and connect them together with the bolts through the spacers. And as I mentioned, these are 12mm nylon spacers. And you can see that what this gives you is a good distance for the pogo pins to come through and protrude above the surface of the top PCB. And they're long enough that they are laterally very rigid. And they're all very nicely aligned. Looking from the top, they basically end up perfectly aligned with the holes they go through. Alright, so the general principle of what we want to do here is use one board to test the other board by having them communicate with each other. And before I get into that though, so I've got these 3D printed guides on it, and there are a couple of different styles on this. You can see that there are guides, and I designed these just so that they would fit perfectly with the spacing, the 12mm spacing when using these. So I bolt the PCBs together and then I slide these on. So here are a couple more of them. I slide these guides on. They just slip on to the two PCBs, and they're a nice firm fit. And then it acts as a guide so that when you put the top PCB onto it, it slides perfectly into position, and then it aligns with the pogo pins. So, and the reason there are two different designs. So these ones are just guides. You can see the profile on that one there. The PCB will drop down between these two guides, and then it bottoms out on that little flat ledge. And that flat ledge, the distance there above the PCB, is designed to be about the right distance to depress the pogo pin. So if I push these pogo pins down until they're approximately aligned with that ledge, that's about where the PCB should be. So if we put our device under test on top of this and push it down so that it bottoms out on all these ledges, all these pogo pins will be nicely engaged. And the ones on the bottom, you can see they're a bit different. They've got overhangs on them. And that is because what I can then do is grab a board that I want to test and hook it under those ledges and push it down, and it will be retained. So if I just push it down at the top, that's now aligned. It's kept horizontally aligned by all of these guides. The bottom can't pop up because it's retained under those little clips. See, so it can't come up. And then as I push down, I've got to get the angle right. So I push down on here, it bottoms out on those flats, and all the pogo pins are depressed, and they're all engaged with the contacts on the bottom of the PCB. So what I can do if I want to do a test on this is just drop the board in there, so hook it into the bottom, push it down, and that's now ready to test. And if you're doing a test that's fairly quick, you could have it so that you put it in there and just push it down, run the test, and then you just lift it up and put it aside. This test takes a little while to run, so when I was doing the tests yesterday, I got into the habit of using these bulldog clips. So I pop it in there, grab a bulldog clip, stick it on there, and then I can just leave it sitting on the bench as the test runs. And that way I'm not touching it, moving things around, causing problems with contacts. And then you just take the bulldog clip off, lift it out. So there's another type of little thing that I want to print. I haven't got any of these printed at the moment, that has like a bail that hooks over the top that's hinged. So what you can do is drop the PCB in, clip the bail over, and then it retains it. You don't need to use clips like this. But anyway, this is just a bit of a quick and dodgy one-off. So by using these 3D printed clips, these guides, and like standard 12mm spacers and a couple of blank PCBs, that's basically all you need to build a test jig. Oh, and the pogo pins, of course. Now, the way this test works is there are a few different things we need to test, but probably, well, it's not the most important, but probably the most interesting is the way it does the continuity test between the pins. So, or the lack of continuity test. So what happens is we have some software that runs on the tester, and we have some software that runs on the device under test, and that is orchestrated by more software which runs on my computer. And this is a little test process that has been developed over the last few days by Andy, who is busy writing code right now, so I'll try not to say his name too often because I'll distract him. He's watching the live stream, but he's also busy trying to write more code for this board. So what he's come up with is really cool. This is something that's going to be, I think, very useful for me for future projects. Because what I've done in the past is whenever I've created a tester like this, I've written something that runs on the tester, and the tester is kind of standalone. And it takes a fair bit of effort because what you have to do is write code for every target, and it's quite different every time. And what Andy has done is made some little MicroPython helpers that make it really easy to create different types of tests and then orchestrate them from a computer connected to the tester. And you'll see that in just a moment. It's really cool. I like this a lot. But essentially what his code does is turn the tester into, it's a little bit like Fermata. So if you've seen the Fermata system that used to be fairly popular on Arduino, although it's fallen out of use recently over the last few years. Fermata is designed to turn an Arduino into a remote I/O board for a connected PC, so that you can do things like read the state of pins, you can control pins, you can do analog reads, all of that sort of stuff, but do it from the host computer via the USB connection to the Arduino. So your Arduino basically becomes like a breakout for your computer. That was what Fermata was for. And in some ways this does the same sort of thing. So there's MicroPython running on the ESP32 on here, and there are some functions that are loaded that allow you to do things like change pin modes, you can read and write the pin states, and you can do different things. And then the host computer connects to the USB on here, and it uses the REPL to interact with those test routines and tell it what to do. So this tester, with those test routines in it, doesn't need to change in order to do totally different tests. All you have to do is change the script that's running on the connected PC that is communicating to the REPL and telling it what to do. So it'll do things like, say, turn all of the pins into input mode and set their input pull-ups on. And you can do that by sending a command via the REPL. And then you can send another command that says, read the state of input pin blah, or read the state of all of the input pins. And then the test orchestration on the computer can use that information to figure out if there are things like short circuits on the board. So what you can do is drive all of the pins into, set all of the pins into input pull-up mode. So in theory they should all be high. And then you read all the pins and verify that they are all high. And then you drive one specific pin low, and then you read all the pins and you verify that that one pin is low and that none of the other pins are low. The others should all still be high because they've still got their input pull-ups turned on. But if any of the others have gone low, then there's probably a solder bridge because you are overcoming the input pull-up and pulling it down with the one that you're driving. And then what you can do is work it round and test every pin in that way. And of course, because it's being done by a script, it's very quick. So it just zips around all the pins and it checks like every possible combination of all the pins high, all the pins low, driving one pin high, driving one pin low, and verifying that none of them are interacting in ways that they shouldn't, and that they are behaving like they are responding in ways that they should. So the way we do that is with the two boards. So if I've got the test D here, which is the device under test, and I want to verify that this is behaving correctly, what the host computer can do is have a USB connection to the tester, a USB connection to the device under test, they both have the test code loaded in MicroPython, and it will do things like, say, set all of the inputs on the device under test to set all of the I/O pins to inputs with input pull-ups turned on, and then it'll drive pins on the tester and read the matching pins on the device under test and verify that the two of them stay in sync. And if they do, you know that you've got good connectivity all the way through the system. There are no short circuits, there are no open circuits, and everything is behaving. All right, that's been a lot of talking. Before I get into actually running tests on this, what are people talking about? More software. Yes. Okay, so some interesting questions. Mako said, do pins that are pressed against pogo pins not wear off? No, the thing is that the device under test is only put onto the tester once or maybe a few times. The pogo pins are used many, many, many times, and they can wear out because the same tester is used over and over again. But the contacts that the pogo pins are making contact with, like, I'll only put this on the tester and run it a couple of times and take it off. So it's not as if there are thousands of connections being made, like thousands of, touches being made by the pogo pins. So that's not a problem. And I was just thinking of something else in relation to flying board testers, but let's not get into that right now because I need to get into some testing. So, where was I going? I was going to talk about something else and I can't remember what it was. All right. There. Let's skip back through some chat. Poor depressed pogo. Thanks, Eon. Yes, I depressed the pogos. Oh, Mako said, how many of you are working together for this? So this is in relation to the conference pad project. There are multiple levels of involvement. There is a core team of probably 5-6 people that are very involved with this. And then there are some other people who are helping out with little bits along the way as well. So yeah, there are a few people involved. Now, so, in fact, I think there are probably credits somewhere on the Open Hardware wiki. The head of the pogo pin. Okay, yes. All right, so some interesting questions here. So Mako said, how does an MCU enable a pull-up? Does it have tiny resistors and tiny FETs? Yes, that is exactly what it has. So if being able to do this trick is dependent on the processor having software-controlled pull-ups and pull-downs. On an ESP32, it has both pull-ups and pull-downs. So internally, it's got the I/O pin, and then there will be a resistor. And the resistor values are not particularly accurate. They vary dramatically, but they're often in the 20k to like 80k ohm range. I can't remember, but I think the pull-ups and pull-downs on an ESP32 are in like the 40 to 60 kilo ohm range. Someone will probably correct me for that. And so internally what it can do is turn on a FET, and it applies a bias to that input pin. A lot of processors only have input pull-ups, but the ESP32 has both pull-ups and pull-downs, which means you can bias the input low or you can bias it high. But the value of the resistor is high enough that if you then apply a signal to that pin, it'll follow the signal. Or you can do it externally as well. All right, so, yep. Where are we? Yeah, so one thing, talking about pull-ups and pull-downs. So if you, I'm seeing a little squirrel off in the distance, but it's only a little one. So if you are using a microcontroller in a noisy environment, like an electrically noisy environment, running a robot or something, my preference is to put pull-ups or pull-downs external to the MCU on the board. A couple of reasons for that. One is that you can bias the pins more strongly and more predictably, because the inputs, the pull-ups that are within a microcontroller are very weak. They could potentially have a spurious signal come in, like say there's a motor that turns on or off and there's a big electrical spike somewhere. The bias resistors on a typical microcontroller are strong enough when the device is in a reasonable electrical environment and it's sitting on your bench or anything like that. But if you've got it in a really bad, noisy electrical environment, I'll typically put like 10K pull-ups externally on the PCB so that you know absolutely for sure that it's got strong enough pull-ups and it's not going to be tricked by other signals flying around the ether. All right, so where are we? Peter, the smoke didn't escape. Very most disappointed. I'm glad that you... Johnny Bergdahl said pull-up value is 45K on the ESP32. Cool. Yeah, so 45K. And as I said, that won't be very accurate. The thing is that resistors on die resistors are very hard to make accurately unless they're laser trimmed. So typically what happens is that resistors that are within a microcontroller, in the manufacturing process, the values can vary significantly. We're used to using 1% resistors. If you use 5% resistors are considered to be, cheap and dodgy, but 5% would be exceptionally good for a resistor that is on the die of a microcontroller. So when they say nominally 45K, they could vary a lot. So putting something like an external 10K pull up or pull down, you know exactly what you're going to get. Now, all right, let's get on to doing this testing. Okay. Just by starting to hook this up, I'm probably going to end up, let's do it over on the side here where you can see what's going on. So I've got two connections here to my computer, and I'm going to show you from the software point of view in a moment. So this is the connection that goes to the tester. So I've now got a USB connection. Should be, if I get the angle right, you can see there's an LED blinking in there. We've got power on the tester, and the tester is already loaded with all of the stuff required for MicroPython. And let me find a board that actually needs testing, and we will see what happens. So, where's the other USB lead? So I've got a second USB lead over here, and I'll jump to that desktop view that you can see off to the side. I'll jump to that in a moment so you can see what's going on. Now I powered this one up, and you can see it's come up saying ICO 0.1 on the screen. You probably can't read that. That's because it had an early version of the firmware flashed onto it, just as part of a test procedure for will it actually load. But we're going to blow that away. So I'll hook that under there, push it down. I'm going to stick a bulldog clip on there. So that device under test, the top board, is now in place sitting on top of the pogo pins, and it's making contact through to the tester using those pogo pins. So let's jump across to the desktop view for a moment. Oh, and also, just while I'm here, this is in Fusion 360, so this is the design for one of the side guides, and this is the design for the little retention clip that goes at the bottom. But let's, what are we going for? Back to terminal. All right, so what I have here is two terminals, and they have some environment variables set. They're both in the same directory, so you can see they're both in ICO engine MP. Oh, hang on, let's drop in a link to this. I checked earlier with Andy. He suggested that we give people access to this because you might want to play around with it. ICO engine MP. Here we go. This is a repo which has a lot of the stuff that in fact, I think it has all of the stuff that I'm talking about in it. And you can see that there are commits only hours ago. This is all very much a work in progress, but making very rapid progress, which is super cool. So this is the firmware for these badges. Well, it's far more than that, but this is what we're using as the firmware on the badges. And it also has the test system built into it. So the test functions that need to go on the tester and onto the device under test are all included in this. And you can see on my terminal here, I am in the ICO engine MP directory on both of these terminals. And the one on the left is the one for, I actually can't remember which one. Is it the tester or the testee? It's got okay, it's got some environment variable set. I'm just pausing, so I'm thinking about how to explain this in a way that is not just me rambling for the next hour. So how about I just get into doing a test and I'll try to explain it as I go, because that'll prompt what I need to think about. All right, so on the right, okay, so the one on the right is the connection to the badge. So this is the device under test. And what I can do is run this script, which is using the MPF flash, and then it's using that to send over, it's using the ico.mpf to tell it what to send over. So this is sending over a bunch of files onto the target device. I've already done this on the tester, so I don't need to do it again. I could do it again on the tester, but you only ever need to do it once. And I've used this tester 100 and something times already. Oh, interesting. All right, so in that case, let's do scripts flash MicroPython. So let's just treat this board as if it's totally unknown, and we'll start by sticking MicroPython on it, and then we'll load our things onto it. So right now, this board on the top, it still says ICO 0.1 on the screen. That's just because the screen hasn't refreshed. The little OLEDs keep retaining whatever last thing you sent to them and told them to put in their buffers, and they will retain it until their power is taken away. So right now, it is flashing, so it's loading MicroPython onto it. This takes, I think, about 52 seconds-ish, give or take. And then once MicroPython has been updated, this ensures that we've got a clean known state on that board. All right, so that board that you can see on the screen now, it's just finished updating MicroPython. So now I'm going to run this other flash script again. So this puts, I'll just jump back to this view so you can see what's going on. So what this does is take the code that is in that repo I just linked to, and it pushes the necessary parts onto the target board. So you can see there that it's made directories. Now it's copying files out of applications, configuration, and libico, and then it's going to copy main.py in a little bit and some other things. So it's got some drivers there like the SSD 1306 that it needs for running the OLEDs. So now on that target board, we have MicroPython and we have the ICO framework with this necessary test code. And so it now should be ready for testing. In fact, if I switch back to the overhead camera, let's see if it's changed. No, it hasn't reset. Normally I wouldn't bother doing this, but I'm going to do it just so you can see what's going on. I'm going to reach under here and hit the reset button. The board will reboot. And oh yeah, so now the screen is showing something different. It says ICO v0.3 and it's now doing Wi-Fi scan, and it hasn't found a Wi-Fi configuration, so it's put itself into access point mode, and it's given me the SSID to connect to, and it's told me what IP address to access to do network configuration. None of that happened before. So that shows that we have now successfully flashed the latest ICO onto it. Now that's not actually part of the test. We needed that code on it, but yeah, so there's some discussion going on about timing on the boards here. All right, now going on this current rate, so it's now 10:54. I started this live stream at 10 and we haven't yet tested our first board. So by my calculations, that means we need 1 hour per board. It's going to take 300 hours to do 300 boards. Yeah, no problem. I need to be a bit more efficient than this. So, okay, so we now have the latest ICO on there and we can start doing some tests. Now, let's see, I'm going to switch back to desktop, and I'm going to do this sometimes with the desktop showing, sometimes with the overhead camera showing, so you can see the result. But for this one, I'm just going to use the desktop. So what I've got here is this little script called scripts_tester.py, and you can see it's got a couple of arguments after it, which are set as variables in the shell. So these, all that does, in fact, let's, I'm going to go back up out of here, echo that. So tester path name, in this case, is the path to the serial port that links to the tester. And if I echo testee path name, so that's the device under test, it's got a different serial port. So that's how this script knows how to communicate with the two devices. And this script that I'm about to run orchestrates the communication between the devices. Like it will send a command to one of them to tell it to do something, and then it will communicate with the other one and see if the link between them is working properly. So let's just run that and see what happens. So what it's done is made connections to the two, well, all that stuff is scrolled off the screen too fast. So it's made connections to the two boards, and it's begun communication with the REPL on each board, so it can talk to it and invoke the functions that are loaded on it. Now you can see that it's paused. What's actually happened here is that it's done all of its cross-testing. So if you look back up here in the console, you can see get GPIO pins value, and this is what it's read back. So it's 1110, 11111, and then the next one down, it's 111110, 11. So you can see that it's progressing along and checking each of the pins in turn. As you can see, it's stepping down here as it goes through those tests. So what it's doing is setting pins to what it expects they should be on one board, and then reading them on the other board and comparing. And if they match, you got a pass. Everything's good. And it knows that there is communication happening between the two boards. So this is reporting the fact the test was 10_13, and these are the results it got. So if any of these things fail, it displays something on the screen here, and you can see it was trying to get this and it actually got this, and the test has failed. But now it's got to the point, so that process ran very quickly. It only took a couple of seconds, and it tested all of the interconnections between all of the I/O pins. That part is really, really fast. But then there are some other cool tests that it does. And this test framework that Andy has written has the capability of doing things like writing messages to the OLEDs and waiting for an event to occur. Now, if you've got a tester that is asserting a pin and then reading that pin to see if it actually is set to the correct state, the timing of that is under the control of the tester. It can set the pin, wait a millisecond for everything to stabilize and then read it, so it's very quick. But if you're waiting for user input, you need to be able to wait for an event, and the fact that it hasn't happened yet doesn't necessarily mean it's failed, it just means the user hasn't done it yet. Right now what it's waiting for is for me to press the left screen to verify that the button under the screen is working. And that's why it says test 11.0. Now let's see, unfortunately it's very hard. Oh, you can read it. See, it says press left OLED. So on the actual board that we're testing, on the screen, it's telling me what to do. It says press left OLED. So if I scroll over here and press the left OLED, that's failed. Interesting. I wonder if that is just because I left it too long. Let's run that test again. I've been sitting here waffling. So we'll let it run through that. It would be rather amazing if we had a board failure on the very first one that I've tried to do today, because the failure rate has actually been incredibly low. All right, now try pressing it. Yeah, now it says press right OLED, so I'll press the right one. And if you could see, you can see on the, I'm trying to point at the screen that you can't see. Here, if we switch back to this view, you can see that it was waiting for me to press it and then it progressed. So as I pressed the screen, it progressed through the next test, and waited for me to press the screen, moves through the next test. So now it's telling me to do the next thing. So it's saying press the top left touch button. So I'll press that. And if you're, it's very small, but if you're seeing the console off on the left, as I progress through following these instructions, you'll see that it is stepping through and giving me output on the console on the left. And I've now tested everything. So if we switch back to the desktop, in the console, you can see it says all tests passed. So it got through all of the stages. So what it did was run the automated tests to check the communication on all of the GPIOs. We verified I2C because the display is working. It then prompted me to press the left screen, then the right screen, then the top left touch, bottom left touch, top right touch, bottom right touch. And it verifies that I've done it and it's detected that event. And you can see on the screen it says all tests passed. So this board we know is good. So that took, yes, 1 hour to test one board. Alrighty, so what I'm going to do is take off that clip, lift the board out, and stick it onto my little pass rack. Oh yeah, so there's another very important point here, which is labels. Where are we? Portable. I'm going to switch to another camera so I can show you what I mean. Alright, so those are the ones that I tested yesterday. The ones that are on the left lying down there still need to be tested. Now, this is the setup that I've just been using. And this little rack, so I did a video a while ago now, quite a few months ago, about how I made these racks. So these are just laser cut MDF that I glued together and then spray painted. And it's just got slots in it so you can put PCBs in it. So these ones are the ones that have passed. And at the moment, I'll show you all the ones that have failed. So I've tested 135 now, I think. And these are the ones that have failed. And you can, so there are 8 in total out of 135 that have failed. And you can see that I've got post-it notes on them saying what failed on each one. So if there was any problem that came up, I put a note on it so that later I can go back and rework those boards or figure out what went wrong. And as you're doing that, you'll start to see patterns coming out. Just going to spin this back around to here. because we're not going to be using that for a little while. Yeah, as you're going through testing, you'll start to see patterns coming out, like lots of failures on a certain button or something. The interesting thing about these failures so far, these 8 failures, is there is almost no consistency. So one of them, the right OLED button's failed, one's the left OLED button. 2 of them have had touch failures. One won't flash ICO at all, so there's probably a problem with the Lowland. And one of them's got both OLEDs failed. Not sure what that one is yet. And one of the OLEDs is working, but it's really dim. So that's not technically a failure, but it's not in a way that I would want to ship it out. So what I'll probably do is just pull that OLED off and replace it. So there is a little bit of investigation to do there to figure out what's going on with those different boards. Yeah, oh, Johnny said that is a decent yield. Yeah, it's not too bad, and part of the reason for that is that we put so much work into pre-testing all of the parts that went on. So as I said earlier, every single OLED was tested. In fact, let me switch back to that camera. I'm going to show you something. You would have caught a little bit of this earlier when I panned around. So if you look down there, those are all dead OLEDs. And that's dead on arrival, out of the box, they just failed. So, and there are a couple of Lowlands that failed as well. But yeah, the fact that we weeded out all of those OLEDs before soldering them on means that we've got a fairly high confidence in the ones that we've assembled, because we've tested the displays, we've tested the Lowlands, and any faults are likely to be just assembly faults like soldering or maybe a PCB flaw. The PCBs all had electrical testing, so in theory they should be okay, but that's not always a guarantee. Yeah. So, alrighty, time for me to run some more tests. So I think what I'm going to do at this point is just run some tests and have a look at the chat while I'm doing it. So maybe I'll be able to get into a mode where I'm kind of on autopilot with the tests and I can catch up on chat while I'm doing it. Oh yeah, one of the points that I was just starting to make a moment ago with those post-it notes is do not ever rely on memory when you're doing this. If you have a board that fails and you put it aside and think, I'll look at that one later, I can guarantee you that half an hour later you will look at your bench and say, why is that board there out of place? And then you'll grab it and put it somewhere that it shouldn't be. Always label things. So if anything fails testing, make sure it's isolated from everything else and it's labeled. You don't want those to end up back in regular circulation. And well, for me anyway, I won't remember because what happens is one of them fails, like a board will fail with one OLED and I'll put it aside and I think, I'll remember that was the board with the failed OLED. And then another board will fail in a different way and I'll put it aside and think, oh yeah, I'll remember that one was with the OLED and that one was with the button. And you come back and look at it a day later and you don't have a clue which one was which or what was wrong with them. So always use labels. And in fact, what I should have is another one of those PCB racks sitting on the side here with like a fail note on it, so that all of these go into the racks. I've just got them sitting on my bench right now, which is not ideal, but I've run out of racks. I've got, how many? I think I've got 10 or so of these PCB trays or PCB racks, and I've just totally run out of them. I need more. So I've got to get myself organized here so that I can sit here and look at the chat while I'm cycling through these boards. So doing these boards does not take that long, despite the fact that it's now taken me 1 hour and 7 minutes to do the first one. It really doesn't take that long once I'm in the cycle of doing it. So if I've got to flash MicroPython right from the start, so I've got to flash MicroPython, then ICO, then run the tester, it's about in that case, it's about 2.5 minutes, I think. If I don't have to flash MicroPython, like I just flash ICO and then run the tester, then it's quite comfortably under 2 minutes to do the test. Yeah, so I can get through a reasonable number of them. Alrighty. So at the moment I am just running the... I'll just flick back to the desktop and show you once again what's going on here. Yeah, so I'm just running those same things as I was doing before. Well, let's have a look, while that's running, let's have a quick look at that tester. So this is the program, or the script that is running on the host computer. So this is what's running on my Mac at the moment, which is orchestrating the two devices. And you can see, so this is the really cool thing that Andy has been writing over the last few days. So you can see it's got a state machine and transitions between different states and all sorts of things. I'm not going to go into this in detail. I'll just give you the general concept of what it's doing. So it's got the two devices that it's setting up and making the serial connections to them. So we've got a list of pins and different things we want to test. And then it's got these functions like check all pins high, check all pins low, and all the different things that you might want to do. And then it gives it a list of different things to test. So there's a list of the buttons on the OLEDs, list of GPIOs, some modes set, and then it does a whole lot of things. So it can store things to the log, and it can display things on the OLED. So it runs through, does a whole lot of pin tests, scrolly, scrolly, scrolly for a long way. And then here you can see that it is prompting on the screen. So it's the log is coming to the screen, I think, in this case. And so it's prompting the user to do something, and then it's checking the result. And then the right OLED screen checking the result. So it then comes down here, and there's some more useful stuff down there. I'm not going to go into that. There are some really tricky things that Andy had to figure out to make this work. There were issues with how to interact with the REPL over the serial connection. So there is a fair bit of magic in here, which I have not even looked at and would have trouble understanding even if I did. So what I'm going to do is ignore that for now and just make this test run. So I'll get into the cycle of doing this while I talk to you. So, oh yeah, so it's got to that point now where it's waiting for me to press the screen, press that screen, then press that screen, top left touch, bottom left, top right, bottom right, all tests passed. Nice. So now we have another happy badge to go onto the good pile. I'll switch it over there. Oh, actually something I was wanting to ask about after the last live stream. Now, I am seeing a very, very large number of skipped frames. OBS is reporting that, well, for this stream so far, 6.9% of the entire stream has been skipped frames because OBS just can't keep up with encoding. And I don't know what that is like from, I mean, I've got stats and I can see on my local screen that things look okay, but I don't know what effect that has on the stream. Like, does it look stuttery to you? Does losing nearly 7% of all the frames mean that this video just looks terrible? I don't know. So Peter Lawler says get a Mac. You're right, it is a Mac. It's a at the time it was a very powerful one. It's a 2013 iMac with an i7 in it. So back in 2013 this was a really fast iMac, but it's rather dated now. But I think it's just having trouble with all the video encoding. Yeah, so as I've been talking to you, I've just been running this script as well, so hopefully I will be able to get into this cycle where I can just sit here and loop through the boards. Alright, so the microcontroller is an ESP32, so yep, so New Ideas is asking what's going on. The microcontroller is an ESP32 on both the tester and on the board that we're testing, and it is being orchestrated by a program which is written in Python and running on my Mac and communicating with both of the devices via serial over USB. So, alrighty, now, what have I been missing? Talk to me, people. What are we going to talk about today? Now that I am more than halfway through. Oh, Peter said looks fine here, by the way, John. Okay, and Axie D92 said a little stutter here and there. Gary Seaman looks fine. Okay, cool. So, it looks like the streaming is still working okay, even though it might be looking a bit strange from my point of view. Alright, come on. Scripts, Flash, MicroPython. This is one that ICO flashing failed, so I've got to flash MicroPython first. Mako says, I briefly saw a jerked frame where part of John's face was more left than the other part. No, that's probably just my normal look. Mike said, servicing the serial port under Python is probably the reason for the frame loss. Yeah, that's enough to stop it. Yeah, the lack of sleep. So, no, it was doing it last week as well, when I wasn't doing anything like this on the live stream. Yeah. Yes. So, if I'm in that weird state now where I'm kind of trying to pay attention to the chat, but I'm also half keeping an eye on this test process. And something I learned a very long time ago is that I can't multitask. It's a... Aaron just asked a very interesting question. It's a limitation of my brain. I know many people say they can multitask. I can't. So what I try to do is stay focused on one particular thing. Otherwise, I'm just not efficient. And so what I'm trying to do now is be part of the machine in the background running these tests and paying attention to when it prompts me to do something, but also reading. Yeah, okay. That's right. So maybe trying to do this live stream and test boards was a bad idea. This was not the cunning plan that Baldrick was proposing. Or maybe it's about as cunning as Baldrick's plans ever get. Yeah. Oh, other interesting things about this tester. Oh yeah, I've stuck some little feet onto the bottom. So I've got these 3D printed pieces on the side, and I've got some self-adhesive silicon feet, tiny little ones, and stuck them onto all of the spaces. So this sits on the, this is actually running the test right now while I'm waving it around. So it sits nicely on the bench, doesn't slide around. Now, what I've been talking about so far is this little sort of dodgy DIY tester approach Now, if you were doing this in a factory properly, you wouldn't do it like this. You'd build a proper test jig, and it would use, do I have an example? All right, here's part of a mechanism from a proper test jig. These come in all sorts of different sizes, and this one is just like the bare mechanism without any of the test jig in it. And the idea is that it's like a little slide thing. So what you do is have a mounting bracket in the bottom where you put your device under test. Well, a couple of ways you can do it. You can either have the pogo pins sticking up or you can have them sticking down. Typically what you would do is have a bed that goes in here with pogo pins sticking up, and you drop the PCB onto it, and then there is a bracket that you custom laser cut or 3D print that goes in here that goes onto the top of your test PCB. So when you push that lever, it pushes it down, and it compresses the PCB onto the pogo pins, or vice versa, and then you can run your tests, and then you let go of it, releases it, the board pops up, and you take it out and put the next one in. So that's what that's the sort of thing that is more typically done in a factory sort of environment. But I'm just using my little 3D printed things here because it was quick and easy. So what I'm probably going to do is, I'm at the stage where I need to grab another rack of boards, and because I don't have enough racks, I kind of have to do this. How am I going to do this? I need another rack clear. In fact, what I'm going to do is take these and I'm going to de-rack them and just lay them out here, because I need a rack that I can use as a destination. So I need to be able to start with an empty rack. And I also need a rack as a source. I need to laser cut some more of these. This is a wider one, but I've got a combination of wide ones and narrow ones. Okay, so I'm going to put that aside. Grab another full rack. So this is a whole rack of boards that have not yet been tested, so that I can begin that process. And where are we up to? Flash. What is up in the chat? Let's see. Oh, yes. Aaron, thanks for reminding me. You did ask that earlier and I noticed it, and I was going to come back to it. Mike, who knows? Unlabeled boards laid out on the bench. Tested, untested, who knows? Yes. I know. Do as I say, not as I do. All right, so Aaron's original question from a little bit back in the chat was, have you seen the new Pi Compute modules? Any thoughts on making the lighting controller a new board with the Compute module rather than just a standalone Pi? That is a really cool idea. Yes, I have seen the Compute modules. I have not actually used one. I don't have one, but they are really, really interesting. I like the idea of being able to design like a low profile mounting location for a Pi. I've done many projects where I've built Pis into things, and there are some limitations because of the things like the position of the connectors can be really annoying, and the profile of the connectors. So the big connector for, I could pull out examples, but I won't right now. So the things like the USB and the Ethernet connector really get in the way with pretty much everything. So I've done quite a few boards where I've put down a footprint for a Pi and then stick it on and use it embedded within the project. but you do need to work around the clearance issues of the headers. And yeah, having a low-cost Pi just as a real credit card size PCB. Oh, which reminds me, it always used to annoy me when the Pi came out. And do you remember in the early days, all of the press was talking about new credit card sized computer. Credit card size. Why? Is it 2mm thick? Let's see. Where's a, I don't even know how thick a credit card is. No, I'm not going to show you my credit card on the live stream, as tempting as that is. Not that you would be able to get anything from it. All right. How thick is a card? Got to have the calipers handy, because if you don't, you can't measure, and to measure is to know. Okay, so 0.82 of a millimeter thick is a standard credit card. And was the Pi 0.8 millimeters thick? No, it was not. Maybe that's just my pedanticism coming out. But that was getting off track. But the Pi Compute module is it is actually almost getting towards that sort of region. It's the same sort of dimensions as a credit card, and it really is skinny. It's, you know, the PCB with not much on it. So when people were talking about the original Raspberry Pi Type A and saying it's the size of a credit card, no, it's not. It wasn't even the size of a deck of cards. It was significantly bigger than that. So please excuse my distraction while I cycle another board through. Oh, Ken, hello Detroit. It is really cool that there are so many places around the world represented here, even though it's a terrible time zone for many people. So back to Aaron's original question. Yeah, so putting that in the light switch controller, yeah, that would be a an interesting thing to do as an optimization. So at the moment, the way the light switch controller is set up, there is an I2C breakout header which connects to either a Pi or an Arduino or whatever you want, basically, with a, ooh, I just got a failure, that's interesting. So whatever you want, using some kind of an adapter board. So I've made up a little Pi hat that has the same header on it, so you just use an IDC cable and plug it in. Ooh, other pins are not low. This one is definitely failing, so I'm going to write myself a little post-it note. And there was a question also about an I2C breakout. I'm going to get back to that in a second. But I'm going to write this one, so it was test 0710 that failed. Test 0710. So again, the nice thing about having each of the individual tests report its ID is that later you can go back and look at your failures and see exactly the point at which it failed in the test. So I can look up what test 0710 is and know what went wrong. So the idea was that the light switch controller, you could put a Pi in it if you wanted to, and that's not necessarily always the correct decision. If you want to make your light switch controller be fairly heavyweight in terms of lots of processing power, so it can also be your Mqtt broker and run Home Assistant or OpenHAB or whatever else you want on it, then yes, putting a Pi in it is fantastic. But that also means that you have a file system which has the potential for corruption if power disappears, and other. It means that it takes a while to boot and those sorts of things. So so that was the reason that in my light switch controller I designed it so that all of the interface boards So the stuff that connects to the front that you plug stuff into, and the displays and the buttons and all of that sort of thing, are all standardized, and then you can use whatever controller you want as long as it supports I2C. And you could just use something like an Arduino, which is plenty fast enough to read from all the light switch inputs and update the display. But it means that if you just pull power on it, it's not a problem, and if you power it up, it'll be booted and ready to go in like 2 seconds. So, and it's a little bit cheaper. So sometimes that is also the correct decision if you don't need all of the other stuff. Ooh, so Aaron's suggestion to that is you could make an Arduino based board, which is the footprint of the Pi Compute module, so you could interchange it. Yes. Now, I also have another version of that PCB laid out, which has an ESP32 directly integrated into it. And my plan was to put Ethernet directly to the ESP32 with power over Ethernet support, and just build that directly into it. So that's one option. Now, someone way back in the chat, I saw this and I actually remember it amazingly, I said that a little while ago on a live stream I showed an I/O board that had a whole bunch of inputs and outputs, and wanted to know what the chip was that's on it. That was an MCP 23017, which is one of my favorite little general purpose devices. I've used it in quite a few different projects, and what's going on with this one? It's having some failures at the touch screen. No, not the touch screen, at the touch sensor stage. So yeah, the MCP 23017 is really useful if you have a project where you've got a microcontroller in it, you might be running out of pins, you want some extra I/O pins. Stick one of those chips in it. All you need is I2C, and you can, and you've got an extra 16 GPIOs, and you can have up to 8 of those chips. So you can have heaps and heaps of I/O, all on 2 pins, because you're still just using I2C. So look that one up. Sorry, I missed the name of whoever it was that asked that question, but it was MCP 23017 is the part number, if you want to go and check it out for yourself. All right. Did I see a reference to Colin? Oh, Colin! Colin Hickey is on the stream. Hey, Colin. Thanks for coming along. Yeah, so have you just joined the stream, or were you on it earlier on? So yeah, you might have, I'm not sure if you saw the early stuff. Sorry, I'm just in the process of looking up some other things while doing this, and yeah, nope. Live streaming while distracted is not a good thing. Ah, cool. Well, thanks for coming along, Colin. Rendo Hin, oh, that's right, yeah, so Rendo Hin was it asked the question. Thanks, or as we say in Estonia, how do you pronounce that? Aitar. I visited Estonia 2 years ago. In fact, it was 2 years ago in like 5 days, something like that. It was just before Christmas 2 years ago. I was in Estonia, and it was an amazing place. Well, when I say Estonia, all we visited was Tallinn, but Tallinn itself was very, very cool. And my very poor memory of that of what we were told while we were there. Someone told me that there are the languages in Estonia are split 3 ways. There are like 3 major languages that are spoken for historical reasons because of different invasions and things that happened over the course of history. So the result is that, unlike most countries where there'll be one language which is universal and then there will be other secondary languages in Estonia, I think it's less unified than that. There are like 3 major languages that many people speak. So anyway, I've probably just told you a whole heap of misremembered lies. So don't take anything I say as being real. All right, so I'm really trying to multitask here. I'm doing my best. So I'm still running these tests. Mako sounds like finish. Yeah, so I only visited Tallinn for a day. I was actually in Finland at the time. So I was over there. This is when I was working for MariaDB Foundation. So I was in Finland because we were all hanging out at Mqtt Widenius's house talking about MariaDB. So Monty is one of the original founders of MySQL, if you know of MySQL, and he then founded MariaDB for reasons I won't get into right now, but basically involving licensing and preserving the open source origins of the project. So actually, maybe that's a random thing I can talk about while I'm doing this. It's not at all related to what I'm doing. So MySQL, the database. So for those of you that don't know, the reason it's called MySQL is that Monty named it after his daughter, My. And the reason that MariaDB is named MariaDB is that he named that after his second daughter, Maria. So, yeah, Monty and, sorry, I've gone blank. It's Monty and a friend of his who created MySQL in the first place, and went through a series of acquisitions and ending up, I think the sequence was the company MySQL AB, so that was a Finnish company, was bought by Sun Microsystems, I believe, and then Sun, not all that long after that, was bought by Oracle. And of course, you can imagine MySQL and Oracle are like deadly enemies. So MySQL being the totally, oh, thanks, Aaron, that's very generous. I really appreciate that. So MySQL originated as a totally open source project. The objective was to make a database that would be free forever and that anybody could contribute to, and it would build up a community around it. And a large part of its success was because of that community. It was built on people like you and me working on it, using it, contributing to it, and helping it become the success that it was. And then the company was bought by Sun, so this is my second-hand version of what happened, so I might be misrepresenting this, but my understanding is that when MySQL AB was bought by Sun, that seemed like a reasonable step to take. because Sun seemed to have some reasonable alignment with the philosophy, or it was doing its best to at the time. And so it seemed like MySQL would end up in the hands of a company with resources, and that would honor the original intention that it should always be open source. And in the meantime, the original people ended up with bucket loads of money and the opportunity to keep working on what they loved working on, so it was a win for everybody. And then, shortly afterwards, Oracle came along and bought Sun. And because they then owned Sun, they also owned MySQL. And I think it was the day of the acquisition, or like the day after, the core MySQL team quit because they would not work under... I've got one here that looks like the screens aren't working. Oh no, that's all right. Because Oracle's approach was basically the opposite of the way they wanted to do things. So what happened was there was the danger that MySQL could end up being subsumed into the belly of Oracle and would no longer be developed in an open and collaborative way, and it could potentially be closed source, like the license could be changed, etc. So what happened was Monty went off and took the last version of the MySQL code base that was GPL and forked it and renamed it to MariaDB. So MariaDB's origins are as a fork of MySQL, and then set it up in an interesting way with two legal entities to ensure that the same fate could not happen a second time. Because what he wanted to be able to do was have, in order for companies to use the database and rely on it, they want a legal entity that they can engage and hire to do things and pay for bug fixes or pay for consulting or whatever they want to do. So then there does need to be a commercial aspect to it as well. The software can be open source, but backing that open source software can be a commercial entity which provides paid for services that allow other companies to rely on that open source software. And that was the course that MySQL was going down, or that had gone down. But that the danger was, and what happened was, that commercial entity ended up being acquired. Excuse me. Hang on a second. Does mute work? No, mute does not work. Because I need to cough. And because it was a commercial entity, it was open to acquisition. So this is the clever thing that Monty did with MariaDB. Instead of just creating the company, they created two companies. They created one company which is the MariaDB Corporation, and that is a commercial entity which you can engage to do corporate, like to do development of databases and contracting and all of those things. So companies that use MariaDB have the reassurance that they can engage a corporate entity that is going to look after them and that will help them meet their corporate, their needs. But he also set up the MariaDB Foundation, and the MariaDB Foundation is I believe it's a non-profit. I'm not sure of its actual legal status. It almost doesn't matter what its legal status is. But the idea is that the MariaDB Foundation is the holder of the intellectual property of the source code of MariaDB, and the foundation is not up for sale. It's something that acts as a trustee and ensures that the database will remain open source forever. And even if something really bad happened to the MariaDB company, the foundation still owns all the source code. And there is a cross-licensing agreement between the two entities. It was set up so that even though the corporate entity is using and developing, I mean, the MariaDB company has a large number of developers, and they are constantly working on the MariaDB codebase and making it better. And all of the code that is developed is I don't know what the term is, pledged? It's not really the right term. But anyway, all of it ends up in the ownership of the MariaDB Foundation by copyright assignment, and it acts as the holder of that IP. So it was basically Monty's solution to the whole problem of what went wrong at a corporate level with MySQL. So anyway, weird backstory. So thanks to my friend Aryan, who was one of the early employees at MySQL, I ended up working a couple of years ago. I was working for MariaDB Foundation, and that is how I ended up in Tallinn, which is how this whole squirrel ended up being chased. I went over to Finland to go to, it was for a meeting, company meeting, and we all hung out at Monty's house, which is ridiculous. That's when you sell your company to Sun and walk away with a bucket load of cash, or bigger than a bucket, walk away with a wheelbarrow load of cash. That's the sort of thing that can happen. Yeah, so we all hung out at Monty's house for a few days, and my family came with me as well for that trip, and so we went to, I need to go back and check chat because I've been just talking without paying any attention to it. Yeah, so my family came over with me, and we all went for a ferry ride over to Tallinn in Estonia, and we all absolutely loved it. It was fantastic. Such a beautiful place. Because it was approximately this time of year. It was I think it was around December 15th or 16th. It might have even been later than that, because we got back we flew back to Melbourne like not long after that, and we were here just before Christmas. So in any case, it was like within a week or two before Christmas, we were in Tallinn and went to the town square in the old town where there was the big Christmas tree, and there were places selling mulled wine, so we drank some nice warm mulled wine while standing out, and the snow was falling and everything was white. It was beautiful. So yeah, very cool place. So Tallinn Estonia is one of those countries that until I went there, I knew nothing about it. Like, I'd heard of Estonia and I knew it was somewhere in that region, but I didn't know what it was like or anything about it. And it's a place that I definitely want to go back and visit. It's simultaneously one of the most advanced countries in the world and has some of the most interesting and longest history. So it's one of those places that is just fascinating. And it has things like, they've had things like online voting for a long time. It's very technologically advanced. So lots of infrastructure in terms of online government and yeah, all that sort of stuff. Lots of high-tech companies originating in Estonia as well. Lots of innovation and really cool things being done, and it's in this environment where there are buildings that date back 1,000 years. So yeah, it's quite an interesting experience. Now, amazingly, just while I've been talking, I've actually got through like 12 boards without really paying attention to what I'm doing. Hopefully I'm not screwing up this tester, but luckily it oh, Della Santos said Estonia is cool, and also Latvia. Yeah, Latvia is a place that I would also be interested in visiting. All right, squirrel time. When so I had a friend at school. I'm just running tests here. All passed. Good. When I was in year 7, so I went from primary school to high school. The primary school that I went to was totally bizarre. It was a little community school that was actually set up by a group of parents, including mine, and they hired their own teacher and got themselves approved by the education department, and and the number of students in the school was between like 12 and 18 or 12 and whatever at any one time. So it was tiny, and that was across multiple year levels. So it was like everybody learns the same thing, no matter what year you're in. It was a bit of an alternative education thing. So what happened was I went from this really weird, maybe slightly hippie-ish primary school, and then, so that was from grades 1 to 6, and the sort of thing where there was no timetable, there were no scheduled classes. It was just whatever the teacher felt like doing was what we did, and a lot of the time we just did whatever we felt like. So yeah, quite a strange experience, and maybe that explains some of the reasons that I am a little bit strange now. I did not have a normal school experience at all. And it meant that there are lots of holes in my education, and there are lots of things that I got to do that other people didn't get to do. So and I was exposed to things that other people weren't exposed to, like different educational opportunities that other people didn't have. So I had this really weird eclectic primary school education where I never learned the times tables, but I was taught quadratic equations and trigonometry and those sorts of things. Like while I would have been equivalent to grade 5 or something when I was learning trigonometry. And I also got to do electronics things, like all self-directed, but there was lots of stuff I got to do at primary school that people don't get to do until at least secondary school and probably university level. But there were things that I just didn't do that other people did do. So now I have these holes in my my education. But I went from that sort of crazy randomness to to St. Michael's Grammar School, which is kind of the opposite. It's everybody has to wear a uniform, and it's all very rigidly organized, and everyone has to comply, sort of thing. And if you don't, you get the cane, because back in those days, even though I think it was illegal in schools run by the in most schools, in private schools there are exemptions, so we would actually get the cane if we did the wrong thing. And yeah, so I went from this really eclectic primary school to rigid secondary school. And anyway, this has all come about because of that thing, yeah, squirrelception. This has all come about because of that comment about Latvia. Okay, so year 7, I went into this, into St. Michael's. So I was wearing a school uniform, and I had no idea what was going on. Everything was structured, and it was like being on a different planet to what I had experienced before. And I felt like such an outsider. I had no idea what was going on. And one of the other people that started that same year, in year 7, was a guy called Victor. And Victor was from Latvia. And I might be misrepresenting this, but this is my recollection of how it went. So he spoke, when he arrived at the school, so start of year 7, he spoke Russian and another language, I can't remember. He spoke a couple of languages, but those languages weren't English. And, or at least very, very little English. So he was in the class, unable to speak the language. And so he went from, at the start of the class, like the start of the year, being totally thrown in the deep end. And by the end of year 7, he was getting along just fine. So yeah, maybe, so De La Santos said Latvians often speak Russian and Latvian. Yeah, so that's probably what it was. I knew he spoke a couple of languages, so I think he spoke Russian and Latvian. I know he spoke Russian, and then learned English like that, and yeah, it was amazing. So he ended up becoming a really good friend of mine through school, and I didn't see him for many, many years, and then I saw him quite a few years ago. We ended up making contact again through Facebook and ended up meeting up, and it was kind of funny because he had a newspaper clipping from way back when we were at school, which had the two of us in it plus a couple of other people, from when we'd made some superconductor material, and we were in the newspaper. So there was a photo that had him and I in it, and a couple of other students that we'd worked with to build some 123 superconductor. So what was it? Yttrium, barium, cobalt, something like that. I can't remember what the materials were. And we did this after school thing. It was not part of the normal school curriculum. It was when Bell Labs was working on the 123 superconductor, and they had just published their results and their method, and a few of us students decided that we were going to reproduce what Bell Labs had done. So we sourced the material with the help of a physics teacher, and ended up making ourselves some superconductor, and that ended up being featured in the newspaper. So that was and he still had the clipping all those years later. So Victor, I'm not even sure where in the world he is right now. I think he might have gone back to Latvia. He was in Australia for a while. Distracted for just a moment while I do this. Oh, I've got a failure on a touch input. Now, one thing that I've discovered as I've been going through these tests, not just today, I noticed this yesterday, is that there is on the ESP32, it has touch input. So that's what we're relying on for these tests for the touch sensors on the front of the badges. So these pads here, these touch sensors, are just bits of copper on the PCB that are connected to pins. And some of the pins on the ESP32 support touch input. And when it starts up, it goes through a calibration routine, because in order for the touch sensor to work, it measures the capacitance between your finger and the contact, but it needs to set a baseline when there is nothing being touched. So when the processor starts up, what it does is measure the input, and it sets that as the zero untouched state. And one thing I've noticed a couple of times is that as I've been running these tests, it'll fail on one of the touch sensors, and then if I just run the test again, it passes. And I have a feeling that what might be happening is that the calibration is possibly being messed up, or it's not. Yeah, I don't know. Maybe it's not having time to run the calibration. Maybe it's because of the other metal around it, because I'm sitting this board on top of a tester. So this is the one that I'm running the test on right now. So it's got these touch sensitive areas here. And then there is another board directly behind it. Well, there's maybe 6 or 7 millimeters of gap there. So there is a bit of a gap, but there is this big ground plane directly behind it as well, and other touch sensors. So it's possible that as it's starting up and going through its calibration routine, the metal that is near it is, yeah, and Neon Signal said maybe calibrating before power is stable. Yeah, so that calibration is part of the power-up sequence of the ESP32. I don't think it's something that you have to invoke manually. It just happens when the chip powers up, or when it boots, or whatever. So I think it doesn't happen very often. It happens maybe like one board in 15. It'll get to the touch test, and then I'll touch it and it won't detect my finger. And then I just rerun the test and then it works fine. So I don't think it's indicative of an actual problem. I'm just pointing it out as an observation, something that I've seen. All right, so I've now got another tray there. So what I can do is cycle. I'll take that tray out. This tray is complete. Whoop. I'll try not to drop all these boards. And I'll grab another tray that is untested. Move it down here and begin the process again. So let's see, I'll slide this one out of the way. I'm just talking to myself. It's like one of those cooking shows where they say, all right, I'm just pouring the sugar into the bowl and now I'm mixing it and then I'm going to do this. Commentating everything I do. And now I'm plugging in the USB and then I'm going to hook it into the tester and then I'm going to put the Bulldog clip on and now the tester is on and now I'm going to load the ICO firmware onto it. No, I'm not going to subject you to that. You know what? I've been doing this for 2 hours. How have I got to 2 hours of doing this? Let me see what I've been missing in the chat. I have not been paying nearly enough attention to the chat. Yeah, so... oh, Pancake Legend. So, Pancake Legend, who you see in the chat, that is Andrew Nielsen, and he is the one who is responsible for the PCB design and the artwork on this. So this amazing looking badge is his brilliance. Yes, and sorry, what I was, so Pancake Legend said there are a bunch of optimizations that we could do to the capacitive sliders that could be explored in a V2. Yeah, so these sliders, the touch sliders at the moment, are a series of interlapping, I can't do this with my hands, are a series of triangles that are sort of, you know, they're going past each other, multiple sets of triangles. And Andrew has been looking into the design of capacitive contacts and capacitive sliders in particular. And because what you can do is you can make things like a circular slider. So imagine what you could do with, say, a volume control where you have a board, I'll just use the back of it. Imagine this logo was actually a series of tracks, like concentric tracks, and they vary in thickness. What you could do is make it so that you could put your finger on there and spin it in a circle, and you could do volume down, volume up, you know, menu selection, all sorts of really cool things. So there are, yeah, there are lots of things that we could potentially do with this to make it even more funky in the future. And Andrew has been looking into that. So, oh, Aaron, I will get back to that question in a second. Andy said, so Andy in the chat here is the one who wrote this code that I'm running at the moment, said, in the code on the first time we read an ESP32 touch pin value, there is a Python try except block to catch calibration problem, and if required, read a second time. Oh, interesting. Okay. So it is already, so Andy's, of course, Andy is way ahead of me on this one. And in his code, it's already doing the try catch to allow that calibration thing to be sorted. All right, I don't have an answer on that one. I'm not sure why it's happening, but sometimes the test on the touch switches fails. Yeah, all right. Now, oh, Peter said, lovely work, Pancake Legend. Yes. Yeah. Ooh, I think I've been missing some very interesting things back in the chat. Simon Wren said, I can see how school can change a person. One time I said to teacher that problem was not able to be solved and the whole class was suspended for 2 weeks to continue after the final year. What? Simon Wren then said, teachers in the old days were never wrong. Yeah, well, the bad ones were never wrong. The insecure ones were never wrong. I had a bit of a mixed bag of teachers, and I had some amazingly good teachers. Some not so good, but I had a couple of teachers that, yeah, that were just brilliant. And one was an English teacher. Early on, I had a couple of really good English teachers, and I also had a very good physics teacher, but early on. My physics teachers in later years were not so good, but early on, like around, I think it was my year 9 physics teacher was excellent. The sort of person that makes you feel like you can achieve things, and that gets you interested in the subject. And he's not there just to assert their authority and work through the lesson plan, and there shall not be any deviation from it. Oh, speaking of teachers, so this just one of the there were several teachers when I was in primary school as well. So the crazy school that I was talking about earlier, we had a few different teachers over the years, and we had, I think one of the first ones was an Irish woman, no, Scottish. I think she was from Scotland. And one of the teachers later on, like when I was in grade 5 or 6, the teacher who took over at school, because there was pretty much only ever one teacher, because there was, as I said, between like 12 and 20-ish students at any one time, and across a few year levels, there would be one teacher for everybody. And what they would have to do is try to come up with things that would be interesting and engaging and actually help people that are at different stages. And there was the teacher who came sort of in my later years, was a guy who his job up until that point, like his previous teaching job, was that he was working, I think it was in far north Queensland, in an Aboriginal community. And so so what he'd been doing was teaching Aboriginal kids in this remote, isolated community, and they didn't have a school as such. It was just running classes outdoors, like wherever they happened to be. So his experience had been with trying to keep people engaged and give them opportunities to learn, and to learn how to learn outside of a traditional school environment. And then he came along and brought that same sort of methodology when he ended up getting the job as the teacher at the little school I was at. Oh yeah, and he had a, he brought his dog with him. He had a blue heeler, which had been with him for years. So he brought his dog back from Queensland when he moved to Melbourne, and his dog would come to school with him every day. So it would always be the teacher and his dog, which kind of just illustrates what it was like. All right, so oh yes. Right, I will get back to your question, Aaron. So Rando Hin said, I believe Greg Devil has a LED ring that uses capacitive brightness control. Yeah, I saw that. That is really cool. So for those of you who haven't seen it, Peter Lawler says lunchtime. Yes, and it is now well after 2 o'clock. So I'm going to wrap up this live stream soon. But first, let me just show you something. This is just a prop by way of illustration. Now, can I find... Yes, all right. Where is one? Now, this is an LED ring, which is used typically like around it. You put a camera through the middle, or like the reason I have these is for microscope. So you can't quite see it, but there is a ring light under the microscope just there. And so what Greg designed was a PCB that I think was a ring light, so it had surface mount LEDs on it, and then he designed a capacitive touch thing into the edge of the PCB, so that to adjust the brightness, what you do is just touch the ring and slide your finger around it. So it'll be like brighter, dimmer, brighter, dimmer. Really clever idea. I saw he posted about it on Twitter a while ago, but I didn't see any updates on it, like whether he got it finished and it was all working, etc. Michael Y said, John's been awake all night. Yeah, can you tell? My brain is all over the place. All right, now I'm going to try to get to Aaron's question. And the thing is that I've been seeing Aaron's... I don't actually have an answer to Aaron's question. Ooh, here's another squirrel. Nick Rapucci said, is it an aluminium PCB? Not that one. This is just a regular, like, fiberglass PCB. But often... those illuminators are done on aluminium core PCBs. So the PCB is a heatsink. So Aaron's question, he said, question you can answer while testing. What's your goals for 2021 and or any resolutions lined up? That, I should have said this earlier. I should have asked this question even if I'm not prepared to answer it, because I'd be interested to know what you have as your goals for 2021 and resolutions lined up. Oh, I haven't been paying attention to the tester. It's been asking me to press the screen. Hey, another successful test. Yeah, I want to know what everybody else thinks about that question. Thanks for bringing it up, Aaron. Now, for me, okay. My goal, I have a general goal for 2021, a couple of goals. One is I need to fix my financial situation, which is now starting to happen, which is really cool. Over the last few months, I've been doing a lot more contracting work, and so I've been getting income from that, which is nice. So I need to, the ultimate goal is to pay off my tax debt and get back into a net positive position, and then be able to move forward. But that's kind of a crappy goal. That's not something that you really aspire to doing. That's just it's just something that's got to be done. The more interesting things are, I want to finish a couple of projects. I've got so many things in parallel, and none of them are quite over the line. Well, some have been. But what I want to do is I need to get the air quality sensor mini-series finished. And now that that video is up, I'm going to make it live for everybody soon. fact, I might even do it today, even though the tutorial is not yet finished. So, okay, backstory to that. I did the first 3 parts of the air quality sensor mini-series, and then I needed to do one about installing all of the software that you need for doing logging and charting. And I've now finished that, and it's uploaded, it's on YouTube. But the written version of the tutorial is not quite finished. So what I've done is made it live for patrons and GitHub sponsors. And it's been live for, I don't know, 4 days, 5 days now for those people. And my plan was to finish writing the text version of the guide and release it to the public at the same time so that everybody can see it. But I think I'm just going to release the video even though the written tutorial is not complete. I can finish that over the next few days, but the problem is that I've had this deadline of doing all of these tests, so that's why I haven't got back to writing that, and the release of the video has been delayed as a result. But I don't want to delay it anymore, so I think I'll just click the go live button probably after this live stream. I will make that video go live, and that video is setting up data logging and reporting using Mqtt, so Mosquito, Node-RED, InfluxDB, and Grafana. And a lot of it is just looking at the terminal and running commands, unfortunately, which is not good for video. But I've got the mostly written text version of the tutorial, which has all the commands in it, so you can just copy and paste. So the video shows you the basic sequence of what needs to be done, but you don't need to sit there and stare at the screen and say, oh, what's he typing on that terminal? You can just follow it at a general level and see what I'm doing in terms of the sequence of installing the software and setting passwords and those sorts of things. And then the web page version has all of the text on it. So for a command that you need to run, you can just copy it, paste it into the terminal, press enter for the most part. And hopefully that will be useful for people. So I've got up most of the way. It's amazing how long, not just in terms of time, but in terms of page length, how long instructions become when you try to be definitive and explain a whole sequence of how to do something. It's easy to start out thinking, oh yeah, it's going to be like, the equivalent of a few screens worth, a couple of A4 pages worth of instructions, and I can step people through doing these things. And then you start writing the instructions, and before you know it, it's long. And that's certainly what's happened with this. So, getting back to Aaron's question, I'm going to finish the air quality sensor mini project because I've got the air quality sensor Pro, which some of you have seen teased on previous live streams. I've held up prototypes and stuff. But the AQS Pro uses the PMS 7003 particulate matter sensor, and it incorporates a BME 680 atmospheric sensor, so it can do things like volatile organic compounds and all the normal environmental stuff, temperature and humidity and air pressure and things. So yeah, and VOCs combined with particulates means that you can have a very small device. So the whole thing is quite small. It's got an ESP32 in it and a color LCD on the front, so it can show numbers and reports on the front of the device. And it can also talk to Mqtt. And that is a really cool little project, but I want to get that finished. But the summary is, I want to get a couple of things finished. And really the only way to do that is to focus on one at a time and just grind on it until it's done. And then move on to the next one. And I keep seeing squirrels. So the problem is that I keep having ideas about other things that I want to build, And the result is that things that I have 80% built don't ever make it to that 100% mark. So my goal and resolution for 2021 is to grind on some of these projects that are not just quite there yet and get them finished. And make videos and share them with everybody, which would be cool. Now, for a little while at least, I can just keep doing. I can run a bit over time now. If anybody needs a hall pass, you can leave now. But I'm just going to continue with this testing, so I might as well run overtime and keep talking while I'm doing it. So I've got through, how many boards have I got through while I've been on the live stream? So there were, that's 20, there was another 20 there, so I've done 40 plus this 6, so I've done 46, and the one that I'm testing right now, so this will be 47, plus there was one that failed, 48. So I've got through 48 boards, and I didn't actually really start on this in earnest until after the first hour, because the first hour I was just explaining all the backstory and talking about testing in general and those sorts of things. So I've done 40 something boards in an hour and 20 minutes effectively. So that's kind of on track for what I would expect for the throughput. And I'd already done 130 something boards yesterday. So that means that we are now up in the ballpark of 180 tested boards. Mako, I did multitask, yes. Amazingly. Yeah, so we're at the point now where we've got about 180 boards fully tested and passed testing, plus the 9 that have now failed testing. Yes. So, Peter Lawler said, got to go. Thanks for the Sunday morning sanity, everyone. Yeah, thanks for coming along, Peter. And yeah, I know you're dealing with some stuff at the moment. I won't mention what it is, but hang in there, Peter. So you're doing very well to be getting through everything. Yeah, it's not my place to mention anything else about that at the moment. It's your story to tell. So anyway, I just wanted to give you a virtual high five and say I appreciate you. So thanks for coming along, Peter. Aaron said, what? Wanted to try and learn sign language and use computer vision to create real-time subtitles. Okay. That makes me want to talk about stuff, but I believe there is an NDA involved, so I'm not going to. I can't. That is a subject that I can't touch because it could get someone else in trouble if I mention it. I'm not going to. Yeah, so what am I doing? I've lost track. I was multitasking and then I stopped. All right, so watch YouTube with me said, I'm interested in home automation and now I'm here at 2 o'clock in the morning. Yeah, well, for now, it'll be 2:21 in the morning. All right, so, a question. Rando Hin said, I have one more question. Got one of your USB to UARTs, micro USB variant, made at JLC that disconnects from Windows once it's flipped to 3.3 volts. What did I screw up soldering the board together? Oh, that's going to be a really hard one to answer. So you've taken the like the Freetronics USB to serial adapter, taken the design, which is cool. So the design files are up on GitHub. That's the reason they are there, so people can see how it works. And just to get this story straight, so what you've done is taken the design files, gone to JLC, got the PCBs made, and assembled it. So you have a recreation of the design, not one that, not one of mine, but it should in theory be the same. Okay, hopefully I got that right. And then when you put it into 3.3 volts, it disconnects from Windows. Now, without seeing the board, that's going to be hard to diagnose, but I'm thinking through possible ways that could go wrong. And what flipping to 3.3 volt mode does. Now, what happens is that USB to serial converter has an ATmega 16U2 on it, and the 16U2 has built-in USB, so it can act as it can connect to a computer, and you don't need a USB to serial converter because it's got one built in basically. So what's happening is that when you flip that switch between 5 volt and 3.3 volt mode, there is a 3.3 volt regulator on the board. So I assume that you have assembled the board with the 3.3 volt regulator on it, and the ATmega can either get its power from the 5 volts that comes from the host, or it can get it from the 3.3 volt regulator. When you flip that switch, what's happening is that it's just changing the source of the supply to the processor from either the 5 volts or the 3.3 volts. And, sorry, distracted for a moment. Test passed, hooray! And the device itself, so the ATmega, is still connected to the host computer in the exact same way. It's not doing anything different. And it should be able to run at 3.3 volts and still be connected to the host. So what I suggest you test is grab a multimeter, firstly, measure the voltage on the input to the voltage regulator. Make sure that you've got 5 volts going into that, because what might be happening is that if that voltage regulator is not working properly, when you flick the switch, the device is trying to get its power from the 3.3 volt regulator, but if it's not getting that 3.3 volts, it just won't run, and then it will disconnect from the host. So that's probably my first thought as to why it's not working. Make sure that you are getting 5 volts going into the regulator from the host and getting 3.3 volts coming out of the regulator. And the easiest way to measure that is actually on the 6-way FTDI header on the end. It's got ground and VCC. That VCC line, or V out or whatever it's labeled, I can't remember, is directly connected to the output from the 3.3 volt regulator. So if you are not getting the voltage it's connected through the switch. So it'll either be 5 volts or 3.3 volts depending on the position of the switch. If you measure that V out pin and it is not one of those two voltages, depending on the switch position, then I think that's the source of your problem. Hopefully that explains some things. All right. Mark, is Mark Merlin here? What? I just saw. Yes. Mark, hey, welcome to the stream. Mark, I just saw your name referenced by Andy, and I thought, what? You're here, cool. Yeah, so Mark Merlin is a very old friend of mine that I've known through LCA. In fact, Mark and I first met at LCA in Perth. It would have been LCA 2002, so 18 years ago, I think, was when we met. And we've been conference buddies ever since. Once a year, we meet up at LCA in a different city, and it's always awesome to see Mark. So Mark is a long-time participant in the Open Hardware MiniConf. Now, I have totally lost the sequence of where I'm at with the testing on this board. I don't know whether I ran the test script or not. So I'm going to run it again just to make sure. And Mark is, I was going to say well known, but maybe notorious is a better way of putting it, for doing crazy LED projects. particularly wearable LEDs, and making clothing that turns him into a human LED display. So he often has crazy amounts of power, like crazy numbers of watts of power that he's wearing. Many amps going through the LEDs. All right, so Michael said Perth has not yet had a flood at LCA. No, it hasn't. Paul Schultz. Hey, Paul. Awesome. All these LCA people coming into the chat, who are in the chat. So Paul said, what would you use to delay the startup of an Arduino that is solar powered? All right, well, that could be done. Oh, what? Something just weird just happened in the tester. I'm distracted for a second. Yeah, the way I would probably do that, if you wanted a long delay, like when you say to delay the startup of something based on that's solar powered, what I would do is I think I would just have a hardware timer, like stick a 555 in it, and set it so that it holds its output low. Now the thing is that there are ways you can also, all right, two ways to solve this problem. If you want your processor to start as quickly as possible after, this one is not responding to button presses. I'm going to run that test again. If you've got a board that you need to start after the supply rails have stabilized. So you might have supply rails that are coming in and they might be wobbling around a bit, and you want to make sure that they're over a certain voltage before your board starts. There are chips specifically to do that, and there is one on the, I can't remember what it is, I'd have to look it up, but it's on the Ether 10 and the Ether Mega. There is it's a chip that is used as a reset controller. What we did with that was there is a chip that reads the supply voltage, and it has an output that you connect to the reset line of whatever your target device is. So in the case of the Ether 10, it's controlling the reset line on the WIZnet Ethernet chip, and it holds that line asserted, so it holds the chip in reset until the supply voltage has been stable above a certain target value for a certain number of microseconds. I think it's like 200 microseconds or something. So the supply voltage will come up, when you turn on power to a device, it doesn't suddenly jump from 0 volts to 5 volts or 0 volts to 3.3 volts. It will come up as a ramp through, because things like capacitors need to charge in the voltage regulator, like in your power supply. So the voltage will ramp up over time, and it will pass through a gray zone where the voltage is high enough that your device could be running, but it's not actually up to its specified voltage yet, and bad things could happen. So you don't want your device to start while your supply voltage is coming up through that range. And that is the reason that we have the reset controller on the WIZnet chip on those boards. And there is this little reset management chip that specifically does it, and it's tiny. It's like a SOT 23-5, and they're not particularly expensive. So that could be a solution to your problem, Paul. Get one of those. I can't remember the part number. I'd have to look it up, which I could do if I fired up Eagle. And that would allow your target device to be held in reset until the voltage reaches a certain threshold. Now, another way to do it, but we're talking here about very fast response. We're talking about something that the voltage is rising because the power supply is just being turned on. We're down in the milliseconds or microseconds region, and we want to keep it asserted, keep it in reset until we're in a stable situation. If you're talking about something that is much longer term, then I would chuck a 555 in it and have it set so that the output is asserted low until a certain period has passed, and then it goes high, and then you'd have that connected to the reset pin, possibly through a diode, or so that it's like a it asserts it when it's low, and then when the timer goes high and its output goes high, it's not actually driving the reset pin high. You can still pull it low with the reset button or whatever. But whenever the output from this timer is low, it's holding the reset low. I don't know if that hand wavy explanation made sense, but Paul, you, I know, are an exceptionally smart guy, and you can probably interpret my hand waves and figure out what I'm talking about. So something I can't remember if I've ever shown it on this. I don't have a power supply set up for it, although I could do it. Paul designed this. You can almost see it if you look in the where is it? The camera. So you can see just there, that grey box sitting up on the top of the shelf. That is a magic. It detects magic. So if there is magic flying around in the air, this will tell you. This thing here, which is super cool, and I power it up sometimes just because it is kind of like magic. It's got 3 Geiger tubes in it, so it's detecting high energy particles, and the tubes are inside other tubes, and they're in a triangular configuration so that it can detect things like the angle of incidence of a particle, and there are RGB LEDs and a speaker. And if you have something like a high energy particle come through, it'll go bong and then show a color. And it's all pretty cool. In fact, what the hell? Why don't I just power it up? Existence of magic confirmed. Muon detector, yes. So Paul, do you remember what voltage this requires? Is it 12 volts or something? I don't know. I've got a bench supply here so I can crank it to whatever we need. Let's find. I'll have a lead here with a 2.1mm plug on it. Now this is totally chasing squirrels, but they are very, very cool squirrels. So somewhere I'm looking for a lead with a, oh, how can I not have one? Maybe, it's in use. I'm looking for a lead that is currently plugged into a Raspberry Pi, but I will have others that are similar somewhere. I thought I did. Come on, I've got to have a DC jack cable somewhere. Up to 19 volts, cool. So I can just stick 12 volts off. Why am I fussing around? I've got a 12 volt lead on the bench right here. All right, I'm gonna move this over where you can see it, and I'm gonna plug this in and we'll see what happens. I'm messing everything up while I'm doing it. Plug in 12 volts. Oh, I heard some noise come out of the speaker. It's booting up, you hear the crackling.
Audio settings, channel 0.
Aha, so it's reported some stuff to us. And these are the different sounds that it's making.
Channel 2.
So, this is part of its boot up process, I think. And then once it is ready to go,
Network settings. Node name Cosmic Array 4-4. Wi-Fi address. Sensor online.
Sensor online. Okay, so it's all booted up. And so this will just sit here and do absolutely nothing unless it is triggered and the muon detector notices something. So what will happen is this will illuminate and it will go boing, and then we know that it has detected a particle flying through us and whatever. Well, there it goes. So it's just detected a particle and it flashed blue. You probably couldn't see that very well on the camera. And there's another one, it's flashed green. And so anyway, the reason all of this came up is Paul Schultz, who is here in the chat, designed and built this, and quite a few others like it. and this was done for an art installation in Adelaide, I believe it was. So these were set out on a lawn on the side, near the river. I've gone blank on it. It is the, what is the big river that runs through Adelaide? Anyway, yeah, change the camera pointing at the bench. Yeah, I will do that, Aaron. So overhead camera, that zoom is no good. All you can see is, I'll zoom out as much as I can. Okay, so that is the camera totally zoomed out, and I'm going to lie this on its side. Which way? That way. So if you were looking at it normally, just imagine that you're looking straight down, but imagine you're looking at this sideways. That's normally how you'd be looking at it. And you can see that it flashes its globe and plays a sound. So these were laid out across a big area of lawn, and people could stand around, and I think the idea was that it was just a reminder to people that there are these high energy particles that are flying through us and around us all the time. And it was a way of doing, just a way of visualizing that and making it obvious that you're standing out here, in a grassy area, and there are these invisible particles, and this made it visual and audible that these things were happening. Anyway, Paul Schultz said, Robert did the hardware. We'll run on recycled laptop battery. Yep. Crystal ball of doom. Yeah. I can go, ooh. Yes, check the aura. See the future. Chris said, John, have you got a luminous watch to show alpha particles? I think I do. I've got an old diving watch somewhere, but I don't even know where it is right now. All right. Now that I've been chasing squirrels, once again, I have lost track of where this board is up to. It's showing the correct things on the screen, so I think it went through the tests, but I don't want one to slip through, so I'm running this test again. And I will leave the camera just pointing at the the muon detector while I'm doing this. River Torrens, yes, James. So that's right. River Torrens is what runs through Adelaide. Yeah. Yes. So, squirrels are chasing squirrels today. I really will have to wrap up this live stream soon because I'm going to have to go and grab something to eat myself. I've actually got through a reasonable number of these boards. I knocked these off while I was trying to set up that muon detector earlier. And yeah, the muon detector is, so James asked, is that a light globe from a ceiling lamp? I don't know where that came from, but Paul is here in the chat, so he can answer all the questions. So it's one of those things that I can't just leave it. I'd like to just leave it up on the shelf turned on because it is a very cool thing, but it goes off too frequently and it's just a little bit too intrusive. Like with this, I don't know whether you're picking up the audio through the microphone very well, but with that running all day, I'll come over closer to it so that next time it's triggered you can probably hear it. But if this was sitting up on the shelf and running all day and it was just constantly making these noises, and now it's making a liar of me because I'm trying to show you. This is the randomness of particles flying around. So you could probably use this as some kind of an entropy source, perhaps, I don't know. See, nothing's happening. I'm sitting here right next to it now and nothing's happening. But if I left this up on the shelf, powered up all day long, oh, my phone's ringing. Who is that? I can't actually tell. I can't see. Oh, hang on. It's my wife, so I better answer that. All right, I will call her back in just a second, but I will end this live stream. Yes, she's calling me for lunch. All right, I'm going to wrap up this live stream because I am way over time now. It's now 2 hours and 42 minutes, and then I will call Anne back. So, I just want to say thank you to everybody for coming along today. This has been a bit of a strange one, but I hope it's been useful to you. So, yes, don't let the wife wait. I will not. I'm going to get off this live stream right now. I'm way over time. Thanks for coming, and I will talk to you all next week. I hope you have a fantastic week, and goodbye. Goodbye.